So one of the things I think I would like to do is just further go in and refine this setup a little bit. Because while this is doing a really great job of breaking up the individual squares, what we aren't getting is a whole lot of these shapes that break the edges of the square, right? Like this shape here. This shape is really cool, but then at the edge of that square, that other shape, this one here, isn't connected to it anymore. So you still end up getting this kind of vague sense of squares or this regular grid. I'm not really interested in that. I want to further break that up. The reason we're getting that is evident back here when we look at the divide sop, right? Because the divide sop is doing remove shared edges. Now, if you remember, way back here, we used the facet sop to break up our islands. So we had all of these kind of island shapes going on. We broke them up into individual polygons using the facet sop so that we could subdivide them and not have those horrible curved edges. But now they're all treated as individual units by the divide sop. So we're still getting divisions along the edges of all of these squares. Now, one way we could get rid of that is by using a fuse sop. So if after our subdivision process, if we take a fuse and we fuse it all back together before our attribute transfer, you'll see what happens here is, first of all, our edges get really gross, but we get these really nice broken up shapes. We're getting rid of those kind of regular grid lines, whereas if I don't have the fuse sop, we have regular grid lines. Now this does cause other issues, right? Because now we're fusing and we're getting these nasty edges. We're getting all kinds of like weird kind of broken geometry and all sorts of stuff. So we have to fix that. But I think there's some merit in doing this. So what we're going to end up doing is all back here before we even do an attribute transfer. So I'm just going to push all of these nodes down. We're going to make a little bit of space for ourselves. And what we're going to end up doing is, let's get rid of this fuse. We're going to group based on what direction the faces are facing. So we don't want to do a fuse and have the edges, we don't want these surfaces fused because this is part of what's causing problems. If I go down here to the divide sop, you can see we've got some nasty overlaps. We've got some like weird gross geometry happening. You can see it really badly down here. We want to prevent these issues by saying we only want to fuse polygons together that are facing the same direction. And in order to do that, we're going to use groups. So we're going to create 6 different groups. We're going to create a group for each face of our cube. And we're going to do fuses based on all of those faces. So we're going to do a group sop, just a regular group sop, not a group expression. And we're going to make these point groups because fuse needs point groups. This is going to be base 1. That's going to be our group name. I'm going to turn off the base group and I'm going to turn on keep by normals. And what that's going to mean is it's going to allow me to define a normal direction and group based on that. So I'm going to put a 0 here. I'm going to put a 1 in X, and I'm going to start reducing this spread angle. And you'll see what happens as I do. Once we get down below 90 degrees, we get only the points that are facing positive in X. And that's it. Nothing else is in that group. Cool. So let's go ahead and make face 2. And we're going to make this -1. So we're going to get the opposite side. And this is face 2. So we're going to do the same exact thing just over again for face 3. And this is going to be 1 in Y. So we're going to get the top points. Face 4. Here, we're going to do -1 in Y. We're going to get the bottom facing points. And we got 2 more. We're going to do face 5, 1 in Z. That's those. And face 6. We're going to do -1 in Z. Great. Okay. So now we have 6 groups that account for each of our 6 faces of our cube. And now we need to drop in some fuse sops, and we're going to do 1 fuse sop for each set of points. So this one is going to be for face 1, this fuse sop for face 2, this one for face 3, nope, 3, this one for 4, this one for 5, and lastly, this one for 6. Now, what we're gonna get by doing that is we're gonna avoid those situations where we have fused polygons that bend around a corner, because that's where we were really having some issues. So let's jump down here to our divide sop. We'll see what we get. Oh yeah, that's way better. No more of those nasty, gross corner edges. Our clean should take care of any overlaps. Yep, normals. And now our poly extrude. Yes, that's much nicer looking. So now we've really lost the sense of that grid. We're really seeing shapes like here that transition across what used to be several individual polygons. Now it's all one polygon, and it's broken up very, very nicely. Super cool. So what I'm going to do now is basically just bring everything all back together. I'm going to come back up here to my delete sop, way back up here. We're going to duplicate this. We're going to say delete non-selected so we can get the regular polygons back. I'm going to take this connection, plug it into here, and I'm going to take the output of all of this, and we're going to throw that back into our merge, and we're going to look at what everything looks like all together. Cool. So that's nice. We do have those regular polygons, and I think maybe what we do is we just get rid of those regular polygons. We let the other shapes be a little bit broken up, and that way we also see a little bit more of that internal structure too, which is pretty fun. Yeah, that's cool. So let's go ahead, and I'm just going to push this off to the side because we may end up doing some more processing with that later. But for the moment, we'll leave it alone. Yeah, that's pretty fun. Let's do some organization, a little house cleaning. Let's take this node, this merge node, we'll push it all the way down here. I do want to throw in a null and just clean this up. This is out. And I think I'm going to bring all of these down here.